Hello everyone, today we're going to talk about anomaly detection within a hydroelectric power plant. Why anomaly detection for electricity everywhere and for everyone? We are two working on this project, myself, Faith Benson, and my colleague, Cyrille. I will introduce myself and he will also introduce himself. I'm a Kenyan, I'm a mathematical scientist and a machine learning engineer. I have a master's degree in mathematical sciences from the University of Cape Town. I also pursued master's degree in machine learning at AIMS, Ghana. In my free time, I like listening to music and inspirational talks to get inspired.
Hello everyone, I'm Cyrille, a Cameroonian data scientist and also an industrial engineer. I have an MSc degree in industrial mathematics from AIMS, Cameroon, and also a master's degree in industrial engineering from the National Higher Polytechnic School of Douala in Cameroon. In my free time, I like learning new things and also helping others.
We need electricity in our daily life in various activities such as heating, cooling. We also need electricity for lighting. We also use electricity for communication, and we also need electricity to run various machines such as drills and the motors. So what happens when we face blackouts? We are going to experience problems such as losses in businesses, loss of communication, lack of security, and even we'll be unable to perform daily operation as I mentioned before. So there are various sources of generating electricity, but here we are going to talk about water-generated electricity. We have a plant which generates electricity. We have water there which flows through the turbine. These turbines turn the kinetic energy from water into mechanical energy, and the generator there it is used to convert the mechanical energy into electricity. After this, the electricity is being transmitted to our various places using the transformer. So in the running process of these plants, there might occur failures due to various reasons such as weather events and even equipment breakages. So our goal in this is to detect, predict, and even explain the failures that might occur in this plant. Why do we need to do this? We are going to do this in order to come up with better scheduled maintenance of this plant for it to be able to run smoothly. So in this project, we use various tools such as Panda, scikit-learn, but the core tool that was used for the data analysis was the PyTorch tool. We used SCADA data, which was in SSV formats. This data had almost 600,000 rows, 78 columns, which represented sensors, which captured different conditions such as temperature and pressure. So this data was collected from July 2019 to April 2021 in a 1-minute interval. To analyze the data, we started with cleaning and also pre-processing using the following processes such as data type conversion, identifying outliers, and even replacing the outliers. After this, we remain with the following rows and columns. At this point, I will allow my colleague Cyrille to continue with the presentation. Thank you.
So after the data cleaning, the first model that we implement was the model called isolation forest. And here we are trying to show you how the isolation forest models works. So here, initially, we have a set of data, and then we randomly put the data into two groups. And we will repeat the same operation until we reach just one point in each group. And then to identify anomaly, we need to compute all the paths to reach the node with only one point and then choose the shortest one based on the contamination. And here the contamination is the percentage of anomaly that we are trying to detect. In this case, for example, we can see that the node 4 here can be considered as an anomaly. So we implement this model in using our data, and we were able to detect about 15 anomalies, but we realized that the model was not working well, and then we decided to move to one of the more complicated model. And then we choose the multi-scale convolutional recurrent encoder decoder model. Why? Because with this model, we can be able to not only detect anomaly, but also identify abnormal time series that are most likely to be the causes of each anomaly. And how this model works? We start by generating a signature matrix, that is by computed the pairwise correlation between the different sensors, and then we use a convolutional encoder to encode the spatial information between sensors. After that, we will use the convolutional long short-term memory to encode the temporal information, and then the convolutional decoder is used to decode the previous information in order to reconstruct the signature matrix. So at the end, we take the difference between the initial signature matrix and the reconstructed one to have the residual signature matrix. And with this residual signature matrix, we are able to detect anomaly and also identify the root causes. So applying this model using our data, we were able to detect 5 anomalies. You can see in the graph, the x-axis here is a time step and the y-axis is anomaly score. And all the time steps that have anomaly score above the red line, which is a threshold, can be considered as an anomaly. And from there, if we pick just one anomaly, we are able to detect the root causes. As you can see from this graph, all the root causes can be detected. And from this case, we have 5 sensors that are the top 5 sensors that can be considered as a root causes. So with this model, the company is able not only to detect anomaly, but they will also be able to detect the sensors that are causes for this anomaly. Thank you for your kind attention, and you can contact us for more detail.
Thank you.